Glad you could join me today. Today I will be looking at OCR specification reference 5.1.5. I want to say L. I think it's L that I'm doing today. This is the muscle contractions. Okay, so here is what you should know. Voluntary and involuntary muscles. Skeletal muscle makes up the bulk of body tissue and is responsible for movement. Cardiac is only found in the heart and it is myogenic, which means it will beat continuously, contracts continuously without any input. And involuntary muscle, also known as smooth muscle. This is not under conscious action. It is found in the stomach, the bladder, and walls of the digestive tract and blood vessels. To look at them in a bit more detail. The skeletal muscle, it is striated. It is under conscious thought, conscious action. It is regularly arranged. It only contracts in one direction. It is rapid. It will have a rapid response, but it's only short. It's only a short time. The fibres are tubular and multinucleated. Then you've got your cardiac muscle. Now this is specialised striated. This is involuntary, so you don't tell your heart to beat. The cells branch and interconnect. It's not fast, but it's not slow in contraction, and it's not fast but it's not slow. If it was too slow, your heart would be like boom, boom, boom. That's far too slow. And if it was too fast, then if the contraction is too fast, it's like boom, 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 it wouldn't contract properly. And the fibres are branched and uninucleated. Then you got your involuntary, also known as your smooth muscle. This is non-striated, involuntary, so not under conscious control. There is no regular arrangement and it can contract in different directions. It will contract slowly, however, it can remain contracted for a long time. It is spindle-shaped and uninucleated. Just in case you didn't know, multinucleated it will contain many nucleuses. Uninucleated, only one nucleus. Alright, the sarcolemma encloses the bundles of muscle fibres. These muscle fibres have cytoplasm called sarcolemma. They also contain many mitochondria for contraction, cytoplasma reticulum, which is their specialised ER, and myofibrils. The myofibrils are organised in sarcomeres, and the sarcomere is one unit. It's one Z line to the second Z line. One sarcomere is made up of two protein filaments: actin, which is thin and held together by Z lines, and myosin, which is thick. The actin and myosin filaments cause different coloured bands to appear in a sarcomere. I don't know if you can see this now. Yeah, you can kind of see it. So, I is the light band, contains only actin, which will be around about there. A is the dark band, which contains myosin and sometimes actin. So over here, this bit right here, that's only actin. You got this bit here, which may contain some myosin, and what contains myosin may be actin. Then you got the H zone, which is this much smaller section here, which only contains myosin. Then you got the neuromuscular junction, which is the end of a motor neuron that forms a neuromuscular junction with skeletal muscle fibre. So this is, instead of going from synapse to synapse, this will be synapse to your motor neuron. Alright, so this is what goes on at a neuromuscular junction. The action potential arrives. The action potential causes the uptake of calcium ions. Calcium ions cause vesicles containing acetylcholine to fuse with the presynaptic membrane. Acetylcholine is released and diffuses across the synaptic cleft. Acetylcholine molecules bind to receptors in sarcolemma, causing sodium ion channels to open. Sodium ions blood in through open channels, depolarizing the sarcolemma. Depolarization spreads down the T tubules. Calcium ions diffuse out of the sarcoplasmic reticulum, and then calcium ions bind to troponin, causing contraction, which we will get to in a sec. Similarities to a synapse. The neurotransmitter is found in presynaptic membranes. The vesicles secrete the neurotransmitter. The neurotransmitter diffuses across a cleft and binds to a receptor. Binding opens sodium ion channels, and enzymes break down the neurotransmitter. But there are also some differences. Diffusion between the differences between neuromuscular junction and synapse. Synapse is neuron to neuron. Neuromuscular junction is neuron to muscle. And an action potential in postsynaptic membrane occurs, whereas in neuromuscular junction, depolarization of the sarcolemma occurs. Actin molecules link together to form long chains. Two actin chains twist around each other to form actin filaments. Actin has tropomyosin in between the two chains, and troponin at random intervals along the chain. Myosin molecules consist of a thick myosin filament and a myosin head. The myosin head has a binding site for actin and ATP. The sliding filament hypothesis of how muscles contract. So with the synapse to neuromuscular junction, we just said that the sarcoplasmic reticulum will have calcium ions diffuse out of it. So calcium ions are released from the sarcoplasmic reticulum and bind to troponin, changing its shape. Tropomyosin is then moved by troponin and unblocks the myosin binding site. With the binding site now exposed, the myosin head binds with actin and forms cross bridges. The myosin head tilts back and releases ADP. ATP then binds with the myosin head. The myosin head hydrolyzes ATP to release the myosin head from the actin. Myosin then returns to its original position. Creatine phosphate in muscle cell sarcoplasm. The phosphate group is transferred to ADP to create ATP. This uses the enzyme creatine phosphotransferase. Something to note is that the creatine phosphatase gives a temporary boost of ATP. However, while it allows this to happen, it generates it very quickly. It actually also runs out very quickly and will only give an extra 2 to 4 seconds of contraction. Alright, so when monitoring muscle contraction, the more powerful the contraction, the greater the amplitude of the electrical signals. And as time goes on, continuous contraction will get weaker. So if I start to contract my muscles here, over time the signal would slowly dip down and my grip would get weaker. And that is everything you need to know about muscle contraction.